Calculate the centripetal force on a 50 kilogram object rounding a curve with a radius of 175 meters at a speed of 30 meters per second. Also, label the tangential velocity, centripetal force, and acceleration for the object. So we have this mass or this object going in a circle. Now in this diagram, I'm going to say that the object is moving counterclockwise. So if we look at the tangential velocity, let's label our diagram first. Tangential velocity, that's the direction of motion at that specific time. So a way to think about this is imagine a car, you're turning a car, and if you hit a patch of ice, which way are you going to go? Are you going to continue to make the turn? Are you going to slip off completely off of the path? Or are you going to kind of continue moving the direction in which you're moving at that exact point in time? And the answer is you're going to move in the direction that you were moving. So if my object here, we have our mass in red. Now we want to take this, and the tangential velocity is simply going to be, again, tangential. So what tangential means, it means it's perpendicular to the surface. If I were to draw a radius to the center of the circle here, it forms a 90-degree angle, and that is always true. So if my object now, let's say, is on the other side of my circle, the tangential velocity in this case here would be straight up. Okay, and you can kind of see as it goes around, it's always perpendicular to the center of the circle. So this is my velocity vector. Now, as far as force and acceleration, well, we know F equals ma. So whichever direction the force is acting in, the acceleration is technically going to be in the same direction. So if we look at this, well, the reason why this mass is able to stay moving in a circle is because there is a force, a centripetal force, that pulls the object literally in towards the middle of the circle. It keeps it from sliding off the path. So this green vector here that we have drawn represents the centripetal force and the acceleration. They're both represented by the same vector. Now to find the centripetal force, we know we have to take mv squared over r. M is the mass, v is the velocity, or in this case the speed, same thing, divided by the radius of the circle in which this mass is turning. So we go ahead and plug in our numbers. Mass 50 kilograms, speed or velocity 30 meters per second. We have to square that value and then divide it by the radius 175 meters, and we get an answer that is approximately rounded 257 newtons. So this number here represents the centripetal force, the force that literally keeps this mass moving at a circle. If that force decreases, all of a sudden this object is no longer going to be able to move in a circle, and it's going to slide off of its circular motion path.